Example 9b, part 1. We are going to be looking at solving exponential equations without logarithms first, before we get into solving exponential equations with logarithms. So, by solving without logarithms, what we're really looking at is we want the same base. They don't need to have the same exponent, but if two sides of your equation have the same base, then the exponents are equal as well. Okay? So let's look at example 1. Right now, my base is 2 and 4. Those are not the same. So I want to think about how I can change one of those to have an exponent and be in the same base. So if you think 2 to the 6x plus 1 equals, well, 4 I can rewrite. 4 is really 2 squared. Okay? Now, both of these have a base of 2. So basically, I'm just getting rid of that. So all I'm left with is 6x plus 1 equals 2. And now I'm solving an equation. So I'm going to subtract 1 from both sides. 6x equals 1. Divide both sides by 6. X equals 1, 6. And that is it. Looking at B, right? B is 2 to the 5x minus 11 equals 16. Same type of thing. I want to get the same base. Right now, these are not the same base. So I have 2 to the 5x minus 11 equals, well, 16 is really 2 to the 4th. So it's kind of knowing your powers. 2 to the 5x minus 11 equals 2 to the 4th. I then want to look right now, I do have the same base. So my bases go away. I'm left with 5x minus 11 equals 4. And from here, I'm just going to solve this equation. So I'm going to add 11 to both sides. 5x equals 15. And I'm going to divide both sides by 5. 5 cancel out. X equals 15 divided by 5 is 3. Looking at our next problem, 4 to the 2x plus 3 equals 1. Right? So 4 and 1 are not the same base. I'm going to change that 1 though. 4 to 2x plus 3 equals, remember, anytime you have 1, 1 is anything to the power of 0. So it's really 4, because 0 is equal to 1. That's a key rule to remember, okay? 4 to any power, or anything to the 0 power is 1. 4 to 0 is also 1. Okay? So now I have my 4s, those same bases. Those are going to cancel out. I am left with 2x plus 3 equals, right? My exponent here is 0. And just solving for x, I'm subtracting 3 from both sides. I get 2x equals negative 3. Dividing both sides by 2. X equals negative 3x. All right, looking at B. It's a little bit trickier. I have 9 and I have 27. Now, 27 is not a power of 9. 9, the first is 9. 9 squared is 81. I skip right over 27. So now I have to think, is there a base that both of these have in common? Well, I'm going to rewrite 9 as 3 squared. And then I still need the 2x minus 5. And then 27 is 3 cubed. So sometimes you'll have to change both of them to a different base. Okay, because they need to have the same base. Once I do that, I need to distribute this 2. This 2 has to go, if it's like a minus or a plus sign, right, it does have to be distributed and it has to be multiplied by both. So this is really 3 to the 4x minus 10 equals 3 cubed. Okay. Now I have the same base, a 3 on this side, a 3 on this side. So 4x minus 10 equals 3. I'm going to add 10 to both sides. So then 4x equals 13. And I'm going to divide both sides by 4. x equals 13 fourths. Okay. All right, there's one more example I would like to show you. Even though it's not on the page, I'm just going to write it. So, if I had something like, I'm trying to think of a good example. 4 x plus 2 is equal to, say, 8 dx minus 3. Now, if you look here, again, I have a 4 and an 8. Remember, 4 squared is not 8. 4 squared is 16. So 4 and 8, right, do have a common base, but it's not 4. Their common base is 2. 2 squared is 4. 2 cubed is 8. And then from there, right, I still need to do what I did last time. I need to distribute. This time I need to distribute on both sides. So I have really 2 to be 2x plus 4 equals 2 to the 3x minus 9. Now I have that common base. So 2x plus 4 equals 3x minus 9. Right? You could always get something that had a quadratic if your exponent had a quadratic in it, so you might have to think about factoring. We're not really going to see many examples like that. Most of the examples we're going to look at this unit are just linear functions or linear equations. So this is linear, there's no quadratic, so I'm getting x's on one side, everything else on the other. So I'm going to subtract 2x from both sides just to keep my x positive. So 4 equals 3x minus 2x is just 1x, okay? Minus 9. And then move my 9 to the other side. I cannot subtract 4 here because the left side is equal to 0. It does not work that way. I have to move it to the other side. So that's 13 equals x. Okay? So x is 13. And that is it. Hope you guys have a wonderful night. I will see you tomorrow.